Okay, for part 2, we're going to write each equation in standard form. Let's see, in my first example, we'll start with something in general conic form. General conic form means that it's totally expanded out. Like this. So it's expanded out, it's equal to 0. Yeah, everything's on one side. And what we're going to do is we are going to complete the square, but I have to do it with both the x's and the y's. So the first thing I'm going to do is I'm going to add this 144 to both sides. So we got 4x squared. I'm also going to group my x's and my y's together. So I'm going to 4x squared, and then I'll do minus 48x plus 9y squared minus 36y equals 144. Alright, so we're going to complete the square. But I see that both my x squared and my y squared have coefficients in front of them, and so we need to factor those out first. So I'll start by doing 4 times x squared minus 12x, and I'm going to leave a blank to complete the square with those. Now I'll do with the y's. So that was, here I'll just make a little separation line. Those were with the x's, and now we'll go with the y's. So we'll factor out 9, and now I'll do y squared minus 4y equals 144. And now we're going to find the value that completes the square for both of these. So once again, we're going to take our middle variable and divide it by 2. So start with the x's, negative 12 divided by 2, and then we're going to square it. Negative 12 over 2 is negative 6. That gets me to 36. But I didn't just add 36 to one side. I added 4 times 36 to the one side. So we need to do it on the other side as well. Let me pull up my calculator. 4 times 36 is 144. So we'll add that 144. Now we can do it for the y's. I'll take negative 4, divide it by 2, and square it. Which negative 4 divided by 2 is negative 2 squared is positive 4. But I didn't just add 4, I added 9 times 4, which is 36. So now for the left side, we got 4, and now I can rewrite that as x minus 6 being squared, plus 9 times y minus 2 all being squared, and all of that adds to 324. And standard form of an ellipse always equals 1, and so like we did beforehand, now I'll just go ahead and divide everything by this 324. And we'll simplify those. And I get x minus 6 squared over 81 plus plus y minus 2 squared over 36 equals 1. And there you go. Okay, next example we're going to look at are going to be equations where we're given the vertices and we're given the foci. Okay, let's see. So with the standard form equation, just going to write that again over here. I need to find h and k, which is the center. I need to find the length from the center to a horizontal vertex, and I need to find the length from the center to a vertical vertex. And so, what do you know about the center in relation to the two vertices? Has to be in the middle. And so I like to sketch it out sometimes because it also lets me know, is it horizontal, is it vertical? And it doesn't have to be a pretty sketch, but I'm probably going to make it one just to point it out easier. I'm actually going to do that over here. 1, 2, 3, 4, 5, 6, 7. And we'll call this -8 down here because it's not changing. So 7, and then -3. And now I can go halfway between the two, which the full length is 10, so that means I'm going to go 5 in. I'm going to mark that in red. So my center is at 2, -8. Okay, so if I know the horizontal distance here is 5. And I don't know B. But C, here's another way we could have looked at the center. It's 2 plus or minus square root 5, so that tells me C is going to be the square root of 5. So I can use this equation of that C squared equals the absolute value of A squared minus B squared. I can use that equation to find B. So I can just plug in what I know, which is square root of 5 squared equals the absolute value of 5 squared minus B squared. So we get 5 equals, I'm just going to drop the absolute value because I don't want to worry about it, 25 minus B squared. Minus 25, we get -20 equals -B squared. Drop the negatives, 20 equals B squared. So I get B as the square root of 20, but I want you to notice that for B, we actually only need B squared for this equation. So great, B is the square root of 20. That reduces to 2 square root of 5. But honestly, once you get here, just go ahead and plug it right in. So to write our equation, we're going to use the center. So I'm going to go x. My center is 2, -8, so it'll be -2 squared over A squared. A is 5, so A squared is 25. And then I have y plus 8 squared over B squared, which I got is 20. That equals 1. Right. Let's do one more just for good measure. If you feel like you got it, you don't have to keep watching. Oh, this one looks good. Okay. Okay. This time I know I'm going to have a vertical ellipse because my y-coordinates are what's changing between the vertices and the foci. This time I can just pick out the center by using that little friend right there. So I know my center is going to be 6, 1. Great. So my distance, my vertical distance, which is going to be b, is going to be from 1 to 8, which is going to be 7. And the distance to the focus is going to be 2 square root 6. So once again, I'll do c squared equals a squared minus b squared. So 2 square root 6 squared is a squared minus 7 squared. Just a reminder, when you are doing 2 square root of 6 squared, it's like 2 square root 6 times 2 square root 6. So I'm actually squaring the 2 and the square root 6. So 2 times 2 is 4. Root 6 times root 6 is 6. And we get 24. Okay, I'll add 49. Actually, I'm going to change this on you. Because I know that this is going to be a vertical ellipse, I actually know that this is going to switch to b squared minus a squared, so I'm going to do that. Yeah. Well, I shouldn't have told people to stop watching. So if you know someone that stopped watching, tell them to keep watching. Because now when I subtract the 49, yeah, that makes that different. So we get a is 5. I only need a squared. So we're going to go x minus 6 squared, or a squared, which is 25, plus y minus 1 squared over 49 equals 1. There you go.